Hola, SAP developers. Welcome to the first session of today's integration track. Before we start, please feel free to drop us your questions on the chat window as we'll be monitoring it and we will answer your questions then. There will also be a Q&A section at the end of the talk. So today we have the pleasure to welcome Vadim again to the Torfest. He was a speaker at last year's the Torfest. He's an integration architect, and he will share with us his experience about developing terminal-based tools for SAP Cloud Integration. Now, without any further delay, hola, Vadim, over to you.
Hello, Antonio. Hello, everybody. Thank you so much for having me back. And it's my true pleasure to attend the Oktoberfest, both as a speaker and as a participant. And this time I came up with a session that will be about developing the terminal-based tools in the context of SAP Cloud Integration. So let's kick off. A few words about myself. So my name is Vadim Klimov. I primarily focus on SAP integration technologies. I also work on some other cloud technologies, like intensive work with BTP, AWS, and Azure. I speak at some technology events around SAP, and I'm a co-author of one of SAP press books related to developing for SAP Cloud Platform Integration. You can find some more information, some materials that I published on the link below. So that's it about me, and let's dive into the session. So the agenda for today, for the next hour, is we will have a short intro about the developer experience and why we come up with terminal tools. And then we will dive into the example. So we will look into the particular specific application. We will look into technology stack of that application, and we will have some demo and walkthrough, just to see how all these pieces play together. Before we come to the main topic of this session, I would like just to talk about key topics that commonly bore the minds of SAP integration or SAP CPI experts. And you see quite a lot of diverse topics that we commonly have to deal with. And those topics are related to infrastructure, those topics are related to connectivity, to mappings, to patterns, to resilience of the platform and integrations, testability, and so on and so on and so on. So we can talk about this a lot. And these are just topics which I could highlight as main topics for cloud integration. It's not even the entire SAP integration. For example, you will not see anything about events in here or anything about API-led, because that's not really what SAP Cloud Integration is about, although it comes into the scope of the wider SAP Integration Suite. Within this session, we will not talk about any of these topics. We will talk about the topic which is not on this slide. And this topic is developer experience. And the reason for that is we as integration experts commonly look into aspects of how we use the platform and how we develop and test and document artifacts. But it's very common that developer experience is left behind. And here I mean not the user experience, because user experience is more common topic. Here I mean the true developer experience. So what tools, what practices, what flows developers use in day-to-day life, and how their experience looks like. And to me, there are several few factors that impact the developer experience, not only cloud integration developer, but developer that uses any other platform. One of them is environment and tools. That's probably the most obvious one. So that's the actual tooling environment setup that developers use in their day-to-day life. So that's all about a variety of graphical tools, IDEs, and so on, tools that build up the environment of the developer. There are two others which are probably less obvious. The first one of them is processes and workflow. So that's what processes are required for the developer to accomplish their job, because that's still a part of the developer experience, and collaboration and communication. Given that unless we are a solo developer, it's more likely that within the enterprise, within groups, we will collaborate with each other, with other teams. And this is how we build the collaboration platforms. And it's not really about the communication tools that we use to call each other or to chat with, although that's also quite important. That's more about platforms with which development tools can be integrated and that enhance the developer experience. So these tools are platforms that are used to host the code base, to host a variety of artifacts, to run different pipelines, and to discuss pull requests, to make reviews, and so on and so on. We will not have time to talk about all of them. And the intention of this session is really to focus more on the tooling aspect. And here, just a brief reminder to ourselves, what types of user interfaces we commonly work with. So what kind of tools we commonly use. The first and the most common is graphical user interface. This is probably the majority of tools that we as developers and as end users interact with on our day-to-day basis. Those are tools which have nice graphical user interfaces. They are commonly responsive and so on and so on. The other big chunk of tools is text-based or terminal-based. And here we have command line interface tools and terminal user interface tools. CLI tools, those are tools which we run from the command line and we interact with the tool using different flags and arguments when we call the command, and we get the output of the command, mostly in the textual representation. And the terminal user interface is commonly the interactive interface that is still executed in the context of the terminal. So quite commonly, it will be textual output as well, but user will be able to interact with the terminal application using the keyboard, not typing the command, not typing the flags they want to instruct the command to execute, but selecting different options on the screen. And this is the group of tools that we will focus in our session. It's not that common in day-to-day life of the developer when they do the development activities, but still, more or less, we all interact with those tools. Sometimes we interact with them explicitly. We truly go to the terminal and we run those commands. Sometimes they are implicit. For example, they can be integrated in our IDE or in our code editor, or they can be invoked by the plugin or extension that we use in our graphical tool. The first question that we need to answer is, why do we need terminal-based applications and tools if we have a variety of feature-rich and user interface-rich graphical GUI tools? And here we come to a few aspects where terminal tools really shine. The first of them is automation scripting. Although we can use those tools on their own, another significant use case for them is we can integrate them into a variety of automation scripts and automation pipelines, which means that we can reuse the same tool for different purposes. And here the limit is only the requirement and imagination. So we can build very complex pipelines that comprise of very different terminal tools that play together. The next one is compatibility and portability. Commonly, a lot of those tools will be portable to different platforms because they are less dependent on the platform capabilities. So, for example, they have basic requirements to the input and output system of the computer or machine, so they can be run on a larger fleet of different machines. They are commonly more lightweight because they don't require a lot of extra UI-related graphical libraries and frameworks. And they are customizable and flexible, because commonly those tools we will be able to customize with the use of either configuration files or different subcommands, flags, arguments, and so on and so on. Uniformity is another thing that may be relevant for some developers in sense that although those tools are different, they have different architectures, commonly there will be some common sense for some flags or arguments that can be used. So the knowledge gained using one tool, to some extent, it can be extended to other tools as well. And it's encouraged for those tools to follow more or less the same principles. They are more performant again, because there are less layers and compute-intense layers that are required for them to run. And as a result of that, the use of those tools can make us more efficient and make us execute work quicker. Because, for example, lesser clicks are required. We commonly will not need our mouse. We will interact with the keyboard, and it's commonly that keyboard motions and presses are quicker to trigger, to execute than to use the mouse. And the last one, which I put in here, minimalistic user interface, is very subjective. So some developers, some users would prefer more extensive interface. Some others will appreciate a more minimalistic interface that allows them to focus on the particular task they are working with, for which they selected the tool they are using. So when we're done with the why question, let's go into the technical stack. So we will pick up one tool that we will work with Cloud Integration tenant, that will work with Cloud Integration tenant. And before we switch to the hands-on, we will have a look into the rationale of the technology stack selection. So when we come to the development of CLI tools and TUI tools, we have a lot of choices for languages, for programming languages, scripting languages. And here I just put a few of them. Literally, it's just the most popular, at least in my point of view, languages which are used to develop CLI tools and TUI tools. And you see the mixture of programming languages, scripting languages coming from different language families in here. So developers, they have the choice of the language they would like to use for the development of those tools. And there are quite a lot of frameworks and libraries for them to accomplish this task. I will not go into advantages and disadvantages of all of them. And the entire list will be way more comprehensive and way more longer if we look into what is technically feasible. Because each of these languages will have their own preference, will have their own advantage and disadvantage when it comes to CLI and TUI development. What I will focus on is the language Golang, or for short, Go. So let's firstly answer the question why Go is appropriate and why I selected Go for the tool, because Go language may seem not very obvious choice for developers who come with SAP background, for example, as myself. So in the integration space, we are more familiar with traditionally ABAP and more recently with Java and Groovy, maybe with JavaScript, but not with Go. So how Cloud Integration developer would arrive to this choice? The first one is the Go language is a statically typed language. And again, that's a debatable advantage of the language. Some others may prefer more dynamic languages. For me personally, the strong typing and type safety is a significant advantage, not for all development requirements, but for the significant portion of those. So there are some use cases where dynamic languages really shine. For example, processing some unstructured or semi-structured data with significant levels of nesting, it may be way easier to develop in dynamic language. And for small projects, it's probably a reasonably good choice as well. But as complexity grows, the predictability and observability of the typing system, to me, it's the advantage. The next one is cross-compiling. That's a significant advantage when we come to tools development, if we would like to have them cross-platform. And Go has native support for that. So we can develop once and we can compile the binary for different platforms and operating systems. Fast compile time. It's not that visible for the users of the tool, but if we need to rebuild the tool often as a part of development cycle, the compile time may matter. And here Go has a significant advantage compared to some other compiled languages. It has rich standard library already. So when we start developing in Go, we already have quite a lot of functions to interact with the different aspects of subsystems out of the box. And it can be complemented with quite comprehensive ecosystem of libraries and frameworks. So there are a lot of them which are available to choose from to plug in your application so that you don't need to develop it all by yourself from scratch. It's quite performant, and what matters to me is it has built-in support for concurrency. So it has so-called Go routines where we can run different parts of the application, different functions of the application concurrently. And which also resonates to me, it has shallow learning curve. So when we come to the Go development, quite commonly, Go will be compared to Rust language for CLI and for TUI development and for other types of application development. And Rust definitely has some other advantages compared to Go. Performance is really one of aspects where it shines. But as the person who doesn't come with a Go background initially, so for me, the technology stack, the original technology stack is the one that is used in the SAP ecosystem. The shallow learning curve was also the advantage, so that I can start building some applications quickly. Now, when we settled the question about why we selected Go, and indeed, other developers can prefer other languages, and it's not right or wrong type of answer. Other languages, as I said, they will have their own advantages and disadvantages. So it's more about weighting up which of them resonate to you as a developer or development team, and which of them matter to you. Now we come to the application. So the application that I will look into is the one that is a terminal user interface application that will interact with SAP Cloud Integration capability of the integration suite. And it's a browser application, so it will not persist any data. It will show artifacts which are contained in the tenant's workspace. So what we will need is we will need some sort of interaction with the cloud integration tenant, and that will be facilitated by APIs which are exposed by the tenant. We will need some other functions within the application. And here, when I thought about how we can represent it, I thought about different architecture styles. So what will be the most illustrative here? And the one that I selected is what you can see here is hexagonal. So we frame it in the way that we have some call logic in the middle. And then we have different ports and adapters which form logical hexagonal, although it can expand to many more capabilities at the edges. So we see one part of it is a data client that will be required to interact with the tenant. We have another module that will be used for configuration management so that we can configure, for example, which tenant to call, which credentials we would like to use. Logging, these are common, I would call it infrastructure level of capabilities. It could have been something related to security, for example, if the application would require authentication. We can think about persistency layer if we would like to save something, and so on and so on. So this list for what we can plug into the application for the infrastructure level, it can grow. And at the top, I placed user interface, a command line interface CLI, and terminal or text user interface TUI. Why I put them opposite to each other? Because literally we can build up a lot of logic, which is shared logic within the application. And then we can decide how we would like to expose it. So do we want this application to be CLI? And then we can work on what kind of comments and what kind of arguments the application can accept. Or we can expose it as or build it as a TUI application. And then we think about what kind of user interface, what kind of rendering we would like to implement in the application. What is important here is that we don't need to develop two distinct applications. The major part of the code base will remain the same. And the major part of the core logic is the same. And then we literally can plug different components and expose them via CLI, interaction with them via CLI and via TUI. So The next one is just as a reference, I put indication of which libraries and which frameworks are used here for different aspects that we described so far. It's indeed not the only choice, so we can choose some other libraries and some other frameworks to implement or to use in the aspects of the application. In here, I have chosen for CLI and for configuration management a few libraries which are quite common in the Go ecosystem. So that's Viper for configuration management and Cobra for CLI development. I used REST as to implement a REST client that will interact with OData. And given that OData APIs, and given that I will use OAuth client credentials authorization flow, I picked up another module which will help me do the job. And for the logging, I used the library called charm-log. And Charm, it's not the only one, the only tool that I used in this application, because the entire part of TUI is built with Charm tooling. So there's Bubble Tea, which is the core, and lip gloss, which helps me to style it. So, for example, to apply certain styles and colors, and so on and so on. So that's quite powerful. It's not a single library; it's a set of different libraries and frameworks that we can leverage for this job. With this, we now come to the demo time. So we will switch off from slides, and we will go to the tooling. So the first one that I would like to show, to look into is, let's firstly see what application we're going to develop. So the application, I published it on GitHub. The application is called CPI Navigator. If you will be interested, I will appreciate if you leave your feedback and ideas, what can be improved or contribute to the application. The application was developed purely to demonstrate that how we can build TUI, and it started to demonstrate how we can build the core of the application and then wrap it as a CLI or TUI application based on the same core logic. Then it diverted towards the more TUI application. So now it gravitates towards TUI. It's a TUI-based application. So that's the one that we will use in the demo. Now, let me go to the terminal. I have already cloned the repository. So the application looks like this. So I started in the terminal, and what I see here is on the left, I see a list of packages of the tenant. And if I click to some, in the bottom, I can see main attributes that describe the package. And then I can click and I can go and look into what are artifacts which are contained in this package. Integration flows, mappings, and script collections. So that's basically it at the moment. I have some ideas what else can be added in here, but hopefully over the time, I will be able to implement those in the application. This is something that commonly we will access using the web API. So if I now go to the same tenant, that would be something that we will commonly see in here. It's literally the same list of packages and it's the same list of artifacts. So if I go to some package, that is the common user experience of the cloud integration developer when it comes to browsing packages and artifacts contained in the package. So this application is literally the other way how we can quickly browse through the tenant. At no means it's supposed to be considered as a feature substitute for the web API. No. So web API is way more feature rich and way more capable. So this application is intended firstly to demonstrate how we can interact with the tenant and how we can fetch this information in a different way. And also it's intended to show how we can use the command line tool for the rapid browsing of the tenant. So as I mentioned, this tool currently, it doesn't allow changing anything. So that's a navigator. It allows us to browse the content. It allows us to look into the properties, attributes of the packages and contained artifacts. It will not allow to modify anything in the tenant or upload anything into the tenant. At least it's not the current intention and use case for the tool. Also, as I said, it's the tool that doesn't have persistency. So whatever you see in here and whatever you browse in here, it's something that is fetched on the fly while the application is running. It's not persisted anywhere on your machine where the application runs. And when you exit the tool, it's gone. So the information is not stored anywhere on the machine. So at the moment, there is no feature to download artifacts, although I'm thinking about maybe it would be worth it to support download of packages or download of artifacts as a feature. So when we got familiar with the application look and feel, let's go to the code. So I'm now in VS Code. That's the cloned Git repository with the application. And we will just briefly match what we talked over the slides with what we see in the implementation, so that you can build this bridge between how it actually matches with the implementation. So the first one is the entry point. So the entry point is quite minimalistic. It literally starts the main comment. So this is where we come to the mentioned Cobra library. So Cobra library is the one that facilitates development of CLI applications. And it's not the only one available in the Go ecosystem, but it's the one that is commonly used. So what we can do here, let me do this. So when we develop a CLI tool using Cobra, we can express and define any comments and subcomments that the application shall support using the Cobra API. So we can define the comment, we can define arguments that it expects to receive, optional arguments or mandatory arguments as flags. And we define what shall be called when this comment is executed. It's not only about the first level of the comments, or we can also add subcomments. So if we have a complex CLI application, we can develop first level of the comments, and then for each comment, we can define subcomments. So literally, it's about building these comment implementations functions for each of comments and subcomments. And then we can also define which flags shall be cascaded to subcomments, or which flags shall be specific to the particular comment, and so on and so on. So that's all that we can implement using this library. Given that the attention of this application at the moment is TUI-based, I didn't implement many comments. I actually implemented just one comment, which is to start the terminal, the TUI path. Technically, as I said, we could have built up extra additional comments that would mimic the TUI path in part of what we can get using the application. So for example, we could implement some extra comments and subcomments to browse the package, or to browse the integration artifact, or to get a list of artifacts in the package, in the selected package. So when we think about Cobra, there are three major parts that we need to think about when we build the CLI command. The first one is the command itself. So what action we would like to execute. So for example, we would like to browse something, or we would like to change something, or we would like to delete something. The next one is argument. The argument is, it's the thing, the noun. So to which entity we would like to apply this action. So for example, we would like to browse the package, or we would like to download the integration artifact. And then the big chunk of implementation is flags. So flags are modifiers for the action. With flags, we can set what extra parameters we would like to pass to this command for it to get executed. So for example, we can pass the flag of the specific type of the artifact that we would like to browse, or maybe we would like to browse on the specific attributes of that artifact. That's about Cobra. Then we come to the part that is the TUI itself. So that's something that we saw when we executed the command. So I will close this part. Don't need to save it. And yes. So when it comes to the TUI, as I said, I use a bubble T framework for this one. And for the bubble T, that's the framework, and there are a lot of so-called bubbles, which are different components that we can plug in our application, or we can develop ourselves. So those are components that can be used in order to build a composite TUI interface. So the framework is based on a few major concepts. So the first one is model. So model is the state of our application. So we define what data we would like to interact with, and what will be state flags or state indicators that we would also like to embed in the application. When I say model, it doesn't mean that we need to use one model. So, for example, this application, different components, different sections of the window that we saw, they are implemented as different models so that I can keep them decoupled. So we have orchestrator model, the common model, and then we have different nested models for packages, for artifacts, for attributes, for status bar, and so on and so on. The next one is when we come to the model, we defined what is the state of the application that we would like to operate with. We define how we would like to initialize the model. So what we would like to execute in order for this model to be operational when we start using it. Commonly, it will be a set of so-called comments that we execute in here. I will come to the comment a bit later. Next one is update. So update is a set of messages or actions that we listen for, that the model listens for, so that it can update its state. So for example, it could be some key presses. It could be some messages that are triggered within the application, which other models passed or which orchestrator model passed. So in here, that's commonly, it will be quite significant part of the logic. This is where we would like to define how the model responds to different changes, to different actions that come up. And the view defines how we would like to render, so what we would like to visualize. And in view, we can define, for example, what styles we would like to use and how we would like the output look like. Now I mentioned comments and messages. These are two critical parts to understand how the framework operates. So comment is the instruction for action. So comment indicates that, for example, fetch packages or fetch attributes of the selected integration flow, or for example, change content package if the application would be changing something. So it's the instruction. The message is the event. Either it's like a notification event, or it can be like a data event. It can store some data that we can further use to change the state, to change the model. So in the message, we can deliver some information that may become useful by other elements, by other models, or by the model itself. So for example, the message can be that content package created, or maybe content packages message, where it will hold the list of attributes for the packages and the tenant. So that's something that we can implement in each model. Moreover, I go back in here. Models can call each other. So here I have the so-called orchestrator model. I will now go back, and we will see for different components, I have their own models. So for example, the one that renders, operates with content packages. If I again expand the code view. So we have some methods, the function that initializes, so it fetches the entire content package list as we start the application. Then the model would like to respond to some messages. So when content packages arrive, then what we would like to do. We have the command to trigger that, to ask for content packages to be fetched. And we have some technical functions that are used to fetch specific attributes of those packages, which can be used by other modules. Here comes the part where we interact with the tenant. So as I mentioned, we fetch content packages and artifacts from the tenant. How do we do it? So in the model, I will briefly go into content packages, and it's something very similar that we can do for integration artifacts. From the command, we can execute functions. So if I go to the function, now we arrive to the part that implements the interaction with the CPI tenant. So it calls the API of the CPI tenant to fetch the attributes. This is where I use REST and two modules. So if I go into the code, so I have one for packages that interacts with API for content packages, and I have the other one that is for integration artifacts. So those artifacts that we can retrieve from the tenant programmatically using APIs, and you can see that we can compose, we can pass extra parameters, dynamic parameters into the query. The question is, from where do we get to know about which APIs to call? And for this, I go to the browser. For this one, our friend is Business Accelerator Hub. So on Business Accelerator Hub, we can get to know a lot about APIs, about event types, about CDS models, and more that is accessible for different SAP products. So now we're talking about integration suite and cloud integration in particular. So let me explore, and I'm looking for APIs, so let me explore APIs. Given it's cloud integration, let me start with searching for cloud integration. Here we go, cloud integration package. And I'm looking for integration content, API reference. And this is the exhaustive information that is sufficient for us to start interacting with a tenant. So a number of these APIs is actually something that is called under the bonnet by the application that we're looking for. So that's a really good reference point for us when we need to interact. And this is something that gets implemented on the client side, how we interact with those APIs in here. So those APIs in part of cloud integration, those are OData APIs. As I mentioned, models can call each other. So we looked into how UI model, orchestrator model called the content packages model. Subsequently, it calls integration artifacts and status bar. And for some of those models, there are already standard bubbles. So for example, for the table, for the list, for a lot of other elements, you don't need to develop it from scratch. So if we look into the package, for example, quite a lot of elements that are not in the package in here, quite a lot of elements that are used in here, they are bubbles which I plugged in. So for example, the list bubble that shows the list of packages. Correspondingly, if I go to the attributes pane, we will see that I just use another bubble which is called table. So they are already provided for you and they are pluggable. And then you can leverage initializer update methods of those bubbles. You can leverage the view. So you don't need to build from scratch how the UI will look like for that component. It's already connectable, pluggable into your application. Now, when we are done with this, a few words about orchestrator. So as I mentioned, I selected the approach where I have the orchestrator UI that gets invoked when we start the application. And then this model will, it's actually the biggest model in this application. It will act as an orchestrator. So it will receive comments, it will receive messages, and then it will know to which nested model it needs to cascade to pass those messages. It's not the only possible choice. So that was my choice when I started this application. But instead of that, you could have selected choreography model. So if you would like different models to talk to each other directly, then you can use that approach as well. my preference for the orchestrator was so that I have the common entry point from where all this kind of orchestration and routing logic is implemented. So I have the access point from where the nested models get invoked. And the other thing which I briefly mentioned, which we have to look into, is we have messages and we have comments and messages, and we have functions. A very good example for that will be the package. So if I again go to the view, we will see that some of functions, they are wrapped into the comment. And we get the message as the outcome of the execution of the comment. Some others, they are just methods or functions. So in this particular case, I implemented methods because they do have the receiver. So they run on the model. We can mix and match both of them. So the major question is it something that we would like to wrap into and embed into the overall framework of the TUI application of the bubble, or if it's some kind of complementary function that we want to just call. And the other aspect that is probably more critical than that is asynchronicity. So as I mentioned, Go supports concurrency out of the box. It has built-in capabilities for concurrency. As you would see from this code, I didn't implement Go routines explicitly to support that. This is because Bubble T takes care for that. And the way how it takes care of that is using comments and messages. So those are asynchronous. So I can trigger the comment, I can listen for messages, and this will be asynchronous. So if we have any operations which we would rather run asynchronously, and for example, communication with OData APIs or with any external APIs, it's a very good example of really good candidates for asynchronicity. We'd rather wrap them in comments and messages so that we can make the application more robust. That's it from the code view perspective. Now I have something else that we can explain here. So we looked into how the application looks like, what we can do with it. We looked into some building blocks of the application to match what we saw on the architecture diagram and what we implemented in the application. Let us enhance it a bit. So if I go to the application, you see that even though I select packages and even though that information about the package gets updated, the status bar remains intact. So I can click in here, I can open the tenant, but it just brings me to the starting page. What if we implement the enhancement that will indicate the link to the package that we selected so that we can navigate right into this package? It shall not be long, so let us start. So I already prepared code snippets for that. So the first part is we need to implement the function that will allow us to get the URL to the package. So this is something that I will do in the UI. So we don't have it now, so I will just copy paste it here. It's not the most comprehensive implementation, so it doesn't cover some edge cases, but it's the minimal implementation that shall satisfy us for now. So we already have the tenant web UI URL, and then based on the selected package, we can compose that link. And if the package is not selected, then we just leave it to go to the tenant itself. Now, the model for the content package has the function to provide that URL. I didn't implement it as a command because everything that we need is computable based on the state of the model or the configuration data that has been already known to the application when it started, for example, tenant web UI URL. So I didn't need to interact with other components. That's why asynchronicity wasn't really the thing that I needed to support in here. So when we have this function, now we need to instruct the application to update the status bar. So to instruct the application to update the status bar, which means that we can pass the message. And for this, I will open UI, the orchestrator, because this is something that in my implementation is done from the orchestrator logic. I will run this part. And we will need to do it in two places. So the first one, content package message. So that's the message which arrives to the application when the initial list of content packages is composed. So when we just start the application. So we have it in here. We update the attribute section. Now let us also update the status bar. So with this message, which is exposed by the status bar component, we pick up the derived URL to the package, and then we pass it to the model of the status bar using the comments that it exposes. And then that's to start with. Then we also would like to make sure that when we go up and down to different packages, we also want the status bar to get updated. So here, that's example of the other message. This is the keystroke, up stroke, down stroke. And if the package pane is selected, I also want the status bar to get updated. I don't want it for now to get updated when the active pane is artifacts pane. So that's something that we can also implement in the future, so that we also have links to the selected integration artifacts. For now, we just do it for the integration content package. Done. Now we need to compile the application. So let me go to the terminal. And for this one, the compiler is built in the Go when you download it. I use the Go releaser tool, which is more advanced builder and packager, and it also allows me to quickly compile for different platforms so that I have a cross-platform application built at the moment. And also it helps me to prepare the builds for GitHub publication. For now, I will not publish anything at GitHub. I created a snapshot without any further checks and just for my machine, so that it's not something that we need to get bothered about other platforms for now. So we will have a dist directory and CPI Navigator, my platform, CPI Navigator. So now when I execute the application, you see that I didn't execute just CPI Navigator because I don't want the binary that is stored in the global directory. I want the binary that we have just built. So that's why I directed the command line to a different location of the CPI Navigator. And now you see that we started the application. We got link straight away. And as we go, we can see that the link gets changed. So if I select some package, we see that the link got changed, and I can click on it. It will open the browser. It will go straight to the package that has been selected. And this one is actually quite large, so it has more than 100.5 artifacts in it. And if we look in here, so you see that it was really quick for us to get a list of those artifacts, properties of those artifacts in here. And the status bar didn't get updated when I navigated to the artifacts pane. It's probably because it wasn't the scope and intention of this minor enhancement that we did. The enhancement works with the package. That is for the demo part. Let me switch back to the slides, and we don't have many of them. So with this, I just want to thank you very much for the time and attention. Thank you for attending the Oktoberfest other sessions. And for this one, my session is over. If you have any questions, I will be happy to try to answer them.
Okay, so the demo gods are on your side today, Vadim. Everything went really well. I really like it. How you end up adding that link to the packages itself and navigating directly to it. I definitely see myself needing that, right? Like in the end, it's like having that quick access is very cool, very cool. There were well, unfortunately, there are no questions in the chat. There was a bit of comments there. Like I did ask around how many have used Go. There were a couple of replies. Thank you for the session. It's a great session. But unfortunately, there are no questions from the audience today. Let me see if I'm not missing anything here. Nope, no questions. Yeah, it was really good. I really like I wasn't familiar with a few of the packages that you were talking about. For example, that bubble tea. Yeah, very cool how you end up organizing everything with that. It does like you can see that you've definitely put a lot of thought on how to structure that UI, right? As in like what was the best sort of way? How many like the sort of way of showing it? Yeah, it was really, really good. So how long have you been working in on CPI Navigator, for example? Like since when the idea sparked, the curiosity sparked, till when you had like a first like sort of not the version that we're seeing today, but at least a basic navigation, right? Mm. How long did it took you? Your development
I'll say that
process?
the first preview, it was something around January, and this is where I was more focused on implementing kind of feature parity between what we see in TUI part and what we see in CLI part. And it was way
Mhm.
more minimalistic from the TUI perspective. So we could run CLI commands to fetch packages and to fetch artifacts. And we could also go into the TUI part and see the same packages and artifacts in the TUI. That was it sparked my interest from perspective how we can reuse the underlying logic and expose it in quite different ways in sense that one is CLI and we have to put some comments and flags, and the other one is TUI, so we can use the keyboard to go up and down and to select. And then it was about January. And then somewhere in spring, I thought that, well, the topic of TUI, I was quite interested in that. And I started to dive deeper into the TUI aspects. And then the
Mm.
application, I literally didn't develop anything CLI related for that application. And I think it's somewhere in April that I made the publication on GitHub about the version that was TUI centric. Um, and after April, I was thinking about usability of the application. I was collecting some feedback about, is it me who is interested in this area, or do others also see some use of this application, and what can be added as features to this application, what makes sense and what will be quite challenging to implement. So I was literally building some kind of internal backlog of wish list, something that I would like to work further to improve this application from performance perspective and also from usability, from UI perspective, which also is not just to use the tool. So I see that it's probably a very niche tool and use cases for the tool, but it's also something that gives me some fresh knowledge and fresh ideas about how we can use different technology stacks which are different from what I got used to when I work in integration suite, and how we can develop some tools using those technologies, or which play with SAP integration suite. So we see here that the integration suite, this is the technology stack that we are, as integration developers, we are more familiar with. And then we have quite a completely different technology stack, Golang, Bubble Tea, which talks with cloud integration. And moreover, the technologies that are used on CLI side and on TUI side, there is nothing that is SAP specific or cloud integration suite centric. So literally, it's quite general frameworks and libraries that we can use to build a variety of CLIs and TUIs for different use cases, for other SAP products, for non-SAP products. So we can think about what kind of automation or what kind of terminal-based tools we require in our toolbox, and then we can start developing them. As soon as we can find APIs through which we can interact with the product, I think this is a significant portion of the thinking, how we will interact and what we would like to do. So do we want to browse? Do we want to change something? Do we want to use this tool for checking, for analysis of the artifacts? Or do we want to run some operations on the tenant using the API? And then the, shall I say, front-end part and core logic part, that's something that plugs in. And then we can, as soon as we started building this knowledge, firstly, we can expand into that. So that's quite broad area. And secondly, we can reuse this knowledge to develop other tools.
Yeah, but like I do see, for example, an integration developer, although like we're used to the web UI, right? And just interacting via the browser. Like I do see a possibility of interacting more with the command line. And I'll give you an example. For example, we have Edge Integration Cell right now, right? Like which is a new product, part of the sort of on-premise offering that we have for SAP Integration Suite. In the end, that runs on a Kubernetes cluster, right? And it's true that you're able to deploy via the UI, but the reality is that if you want to interact with Edge Integration Cell, like there's Kubernetes there, so like you can easily use kubectl to see all the components that have been deployed and to actually connect to the database that's running there, to see, for example, logs and see how your pods are running. So it's true that as an integration developer, traditionally you didn't have to interact with the CLI that much, but if you're in a customer that has Edge Integration Cell and you want to really know how things are going in Edge Integration Cell, it is likely that you need to open up a command line and use kubectl in order to see the state of that Kubernetes cluster when Edge Integration Cell is running, right? And I don't know, I see how this, for example, can be part of the flow. Like the APIs are still relevant, as in interacting with the artifacts that are deployed there, right? Yeah, you can use, for example, a tool like CPI Navigator to see, I don't know, the particular artifacts that are deployed to a particular runtime, right? In that case, Edge Integration Cell. Yeah, so it is possible that in the future we will need to do a bit more of our command line stuff. I don't see why not. So
Yeah,
yeah,
I absolutely agree. It feels like as much as responsive UI and graphical user interface and web development evolves, that much CLI development evolves as well. So we have more and more CLI tools, terminal tools in general, that evolve as well. And especially with the
sure.
rise of APIs that we can access programmatically from a variety of tools. And also with the rise of automation and the approaches like CI/CD, we have more and more need in the tools that we can embed in the pipeline. And most likely, it will be tools that are command line based, command line interface based.
Cool. Well, you know what? There are no questions in the chat, so I think we can end up wrapping up just before the hour hits. Thank you very much, Vadim, for sharing all your knowledge and expertise as part of this session. It was great to have you back in the Oktoberfest. And yeah, thank you very much for this. Anything
Thank you
else
for
that you want to
inviting.
add?
Yes, thank you very much for inviting me
Oh,
here, for having me here for the whole hour, and also for those who participated, or maybe for those who will listen and watch it in recording. Thank you very much for your time, for your interest. And shall I say that CLI topic and tools topic, it's not the only session on the Oktoberfest. So we had really great sessions last week, which show
yeah, love.
different angle how different tools can be used and how they can be embedded. And there are lots of tools that are developed by SAP, by third parties, but also by community. So
Very
this
true, very
topic
true.
is definitely something that is quite demanded.
Definitely true, definitely true. So yeah, well, this, as Vadim correctly highlighted, there is plenty for everyone to learn during the Oktoberfest. If you didn't manage to watch some of the sessions last week, so make sure to check them out. They're all recorded. There are also more live sessions happening. We have a couple more of today as part of the integration track. But whatever your topic of interest is, it is likely that we have something for you as part of the Oktoberfest. So make sure to check out all the different sessions that are part of the event. And that's it. Thank you very much.
Thank you.
Gracias.
Bye-bye.
Ciao.